Section 4.5, Exponential and Logarithmic Equations. So finally, after all that review, we are ready to put that information to use to see how to solve both exponential equations and logarithmic equations. We're going to start with exponential equations. So there's different types of exponential equations that you will encounter. So I've kind of broken this lesson up by the different types of exponential equations, and I'll do the same for logarithmic equations. Okay, so the first type of exponential equation that we're going to learn how to solve are exponential equations that you can write in one of the following forms. Either a to the u is equal to b, or you can write it in the format a to the u is equal to b to the v power. Okay, and I know that may seem like, what are you talking about? Well, this is what I mean, okay? If it's written in this format, what I'm saying is you can write your exponential equation as follows. You can make it look like an exponential term, the piece with the exponential term on the left is equal to just some number on the right. Okay, so that's one way you can make your exponential equation look. Or if it's written in this format, you can make it look like exponential term number one. So you've got something with an exponential piece, and you can isolate it on one side of the equation, and on the other side of the equation you also have an exponential term. It's just a different exponential term. So I'll call it exponential term number 2. Okay, remember, if it's exponential, that's going to be the little piece that has the variable as part of the power. Okay, so the directions that follow apply if you're able to get your exponential equation in one of the following formats. Either you've got that, you can isolate the exponential term and you have it equal to a number on the other side of the equation, or you're going to be able to rewrite your equation so that it's one exponential piece equal to another exponential piece. Okay, you might have to do some algebraic manipulation to make that happen, moving things to either side of the moving things over, like move this term to the left or move this term to the right to make that happen. You also may need to use the law of exponents to make this happen. Okay. All right, so let's kind of walk through the process of doing this, how you would solve an equation that looks like this, and then we'll do some practice. Okay, so the first thing you're going to want to do, like I said, is isolate the exponential term on one side of the equation. Okay, that's going to be this first thing I wrote down, where you are able to make your equation look like an exponential term equal to just a number. Or you can also, it says this procedure also works if you are able to isolate a single exponential term on both sides of the equation. Okay, so that would be the second thing I mentioned, where you can make your equation look like an exponential term equal to another exponential term. Okay, all right, so after you're able to get your equation in that format, you're going to take the logarithm of both sides. Okay, I recommend using either natural log or using base 10, log. Okay, yeah, you may want to use log base 4 or log base 9, but my recommendation is to use ln or log, because those are the buttons that you see on your calculator. All right, so then you're going to apply the third major property of logarithms, okay, where you have the natural log of a quantity raised to the r power. That's equal to r times the natural log of the quantity. Okay, that property works for natural log. It also works for log. Okay, so we're basically applying the third major property of logarithms. Okay, the reason we're going to use that property is because this is going to free the variable from the exponent. Okay, exponential equations are difficult to solve because the variable is trapped in the exponent. So that third major property of logarithms frees the variable from the exponent. Okay, then once the variable is freed from the exponent in step 4, you'll be able to solve for x, or whatever variable you're using. Okay, all right, in step 5, usually when you're solving equations, the great thing about solving equations is you can check yourself. You basically check, you take your solution, you plug it back in and make sure whatever you plug it into the original equation, make sure it's true. The equation holds true for that number that you got as your solution. Okay. In step 5 here, it says it's not necessary to check your solutions in the original equation. It's always a good idea to check yourself, but it's not necessary. You're going to see that when we solve logarithmic equations, it's going to be absolutely necessary to check your solutions when you're solving a logarithmic equation. Okay, so for exponential, it's recommended but not required. Okay, all right, so just to sum up before we try this, okay, you want to isolate your exponential term either on one side or both sides of the equation. Once you've done that, you're going to take the logarithm of both sides using natural log or log. Then you're going to apply the third major property of logarithms, okay, where you have the logarithm of something to a power, you can bring that power down in front. That will free the variable from the exponent and allow you to solve for the variable. Okay, so here we go. Example 1. Solve each equation. Give both the exact value for x and a decimal approximation to the nearest thousandth. Okay, so one thing I want to mention, when you see, and this goes for the entire semester, if you are asked to give an exact value, exact means no decimal. Okay, so when you're solving something like this, you might get some funky looking answer. That's going to be the exact form, and then you're also going to be asked to punch that funky answer into a calculator and give a decimal approximation. You need to be able to do both. Okay, all right, here is our first exponential equation. Okay, in part A, we need to figure out the value or values of x that make this a true statement. 8 raised to the x power is equal to 21. Okay, first of all, recognize this is an exponential equation. You've got an equal sign, okay, and then the variable x is located in the power or exponent. Okay, so we're just going to kind of follow the steps that I've outlined for you. Okay, the first thing you want to do is take or locate the exponential piece. Okay, the exponential piece is the piece that contains the variable in the exponent. Okay, so the exponential term here is 8 raised to the x power. It's isolated. Okay, it's all by itself on one side of the equation, and the other side is just a number. Okay, so it's in a format that we can work with. Okay, so we're going to go ahead and just start working. Okay, we've got the exponential piece isolated. Okay, for example, if you had had a 3 multiplied out front, okay, you would have needed to divide off the 3 before proceeding. You've got to get that exponential piece alone. Okay, all right, so we have that. So what we're going to do is we're going to go ahead and take the logarithm of both sides. It's your choice, okay, if you want to use ln or if you want to use log. Okay, in certain situations, it's going to be better to use one or the other. For example, if your equation involves e, you're going to want to use ln because those two guys are inverses of each other. If your equation involves a 10, you're going to want to use log. But here, the base of the exponential is 8. Okay, so you could use log base 8, but that doesn't have a button on my calculator that I can easily access. Okay, so I'm going to use ln or log, and it doesn't matter which one you use here. You'll get the same answer. I'm going to use log. Okay, but you could use ln. So we're going to take the logarithm of both sides. Whatever you do to one side, you have to do to the other. Okay, so the log changes things. For example, on the right side is no longer 21. It's the log of 21. If you put log of 21 in your calculator, that's going to be some nasty decimal. So it matters that the log is there. Okay, all right, so we've taken the log of both sides. Okay, we are trying to solve for x. So the reason we did this is now the left side is the log of something to a power. So we can apply that third major property of logarithms that says if you have the logarithm of something to a power, you can bring that power down as a multiplier. So the left side is going to turn into x times the log of 8. Okay, log of 8 just some nasty decimal. Okay, we haven't done anything to the right side, so it's going to stay the log of 21. Okay, so we have gotten x out of the power. It's going to be a lot easier to solve for x because it's no longer trapped in the exponent. Okay, so x is multiplied by the log of 8. That's just a number. So if you want to solve for x, all we have to do is divide off this number. We're going to divide both sides by the log of 8. Okay, so then on the left side, log of 8 divided by log of 8, those guys are going to cancel. X is going to be the log of 21 divided by the log of 8. Okay, this is the exact answer. Okay, there's no decimals involved, and we've solved for x. Okay, all right. You have to give both an exact answer and a decimal approximation. So now I'm going to march to my calculator and punch this in. Okay, punch it in just like you see it. You need to use log. Okay, this is the log of 21 divided by the log of 8. Okay, here's your answer, your decimal approximation. Okay, so you can see what it is. I'm going to go back to the directions. It says round to the nearest thousandth. Okay, so I'm going to go ahead and say x is approximately, and then I'll count out this thousandth. So after the decimal, you're going to have the tenth, hundredth, thousandth. So it's going to be approximately 1.464. Okay, so I'm going to write that down, approximately 1.464. Okay, and here is your decimal approximation. Okay, all right, something I want to point out. Okay, do not make the mistake if you see this. Okay, this is not the same thing as the log of 21 over 8. Okay, if you went to your calculator, okay, log of 21 over 8 gives you a totally different answer. Okay, so don't do that. Okay, the answer is the log of 21 divided by the log of 8. Okay, all right. If you had instead used ln instead of log, your answer is going to come out the same. Okay, it's going to look different, but you're going to get the same result. Okay, so just quickly, if I had started, let's start over, but we use ln instead. Okay, so we take the natural log of both sides, and then we apply the third major property here where we bring down the x. It's going to follow the same steps. All right, so we'd have x times the natural log of 8 is equal to the natural log of 21. And then natural log of 8 is just a number, so divide it off. So you'd get pretty much the same answer. You would just have ln instead of log. Okay, watch what happens. If you go to your calculator, okay, let me get rid of what I just wrote because it was wrong. Originally, we had log of 21 divided by log of 8. So this is the correct answer. But if I had used natural log instead, okay, you would get the same answer. Okay, so it doesn't matter if you use log or ln. You just need to pick one and be consistent. You don't want to mix logs with natural logs. Okay, so either one works. It is your call.